Question 2 is all about the small angles approximation. And you can look up in the formula book that the small angle approximation for cos theta is it's 1 minus theta squared over 2. So all we've got to do is try and work through this, but being careful with our brackets and everything. So we've got 1 plus 4 lots of cos theta, which we've just said is this, plus 3 lots of cos theta all squared. So working this out, I've got 1 plus 4 minus 4 times theta squared over 2 gives me this. And right, we're going to take this bit a little bit more carefully. So I've got 1 squaring this bracket here then gives me minus theta squared, and then at the end here I've got plus theta to the 4 divided by 4, just those bits squared. Timesing all of that by 3, I think to save writing it all out again, I'm going to put a 3 here, I'm going to put a 3 there, and I'm going to put a 3 there. And are we nearly there now? What are we looking for? So we've got 1 add 4, 1 add 4 add 3, which of course is indeed 8. I've then got minus 2 theta squared minus another 3 theta squared, which is minus 5 theta squareds. And, well, the extra bit here is theta to the 4 over 4, 3/4 of that. And what we're going to say is that because theta is so small, we're going to ignore that part there because it's so small. So that's the bit that we wanted. Now Adele's thrown in 5 degrees to try and see if this works. And the big problem that she's got there is it only works for radians, not degrees. And so you can't throw in 5 degrees, it won't work. But what we could do is change what 5 degrees is into radians. 5 degrees is actually pi over 36 radians. And if you put that, and you've got 2 marks, so you've got to put it into both sides of it. So if you put that into this formula here, then you're going to end up getting 7.962. And if you put that into just this part here, then that gives me 7.9619. And so we'll now put a little statement that's saying at theta equals pi over 36, both give similar